Okay, done.
Oh my god.
I don't really care what you did in your break. Just kidding.
I got a calculator.
Hey, we're gonna use it though. Okay, so next week we are gonna have a midterm. It's gonna be multiple choice.
I mean, that's still not good.
Multiple choice. It's all AP exam questions. So that means you can guess, even though,
25% chance.
yeah. Except I think there's 5 choices, so you have 20% chance.
Is this a test for like if we do well at it, then like we get different place higher score or something?
Yeah, but more likely you're not gonna do well.
Aw, nice.
But it's an AP scale, so it's gonna scale by AP exam. So that means 70%. That's a A. So if you just know 70% of material, technically you only need to know 55% of material, and got really lucky to the rest of 15%, then you'll be fine. Yeah. So some people are good multiple choice question test taker, but in this case, it's not like this. Okay, so so now we're gonna start with this new section, and the new section is called antiderivative. So let's do it. So the new section is about its antiderivative. It's antiderivative. Okay, so that means, do you see it now? Okay, antiderivative. Derivative. And a lot of time, that antiderivative is also known as. Let's start with a derivative first. Do you guys remember what's derivative mean? Yep, to find slope, right? SLOPE. This 5 magic letter. Or you can find the rate of change. Usually that's also known as that. Or in IB, you guys don't have IB here, but it's called gradient. So, and you might see gradient in the future, because that's what I call sometimes in college as well. So slope, rate of change, gradient, equation, tangent, slope. There's so many other things that can represent derivative. But main thing is the slope. You can find slope of function. What is antiderivative? Antiderivative is also known as a indefinite integral. Indefinite integrations, or integrals. Basically, the goal of antiderivative is to find, what if I give you f prime of x, right? And we say, what does the f of x look like? Well, we didn't ever ask that question, for that matter. We just asked you what happened with the f of x. So we didn't ask you, what does f of x look like? We just say, well, what's the main characteristic you see on f of x from f prime x? You can find the maximum, minimum, inflection point, concave up, down, increasing, decreasing. And those are the big part of the AP exam. And if you know how to do that, you win. Like I said, you don't need it to know everything in calculus. Matter of fact, you don't even have to know arithmetic to get a 3 on AP exam. You just know the conceptual ideas, you can get a 3 on AP exam. So it's very important that you know all those conceptual ideas. So antiderivative is also known as indefinite integrations. Now we're going to talk about what the antiderivative is. So let's just say if f of x, right, is equal to x to the third. Now if I take a derivative of x to the third, that is equal to 3x squared. So that means x cubed is the antiderivative of 3x squared. Does that make sense? Or f of x. The f of x equal to x cubed is antiderivative of 3x squared. Because 3x squared is derivative of that. Questions? Any questions before I move on? Super simple. It's just reverse. Math, if you realize math is always driving forward and driving backward, driving forward, driving backward, driving forward, driving backwards. When we talk about square function, we could talk about square root function. And when we talk about positive slope, we talk about negative slope. It's always like yin and yang, right? So let's talk about definition. Definition of antiderivative it's basically a function. So there was a function, and that's not any function. This function is called f. Is an antiderivative of f. So the small f, derivative of f. This is a red f. See, one is capitalized, one is non-capitalized, so that you can differentiate. If I take the derivative of big F, I got a non-capital F. Does that make sense? Does that make sense? So on an interval, and we're not going to call it interval, we're going to call it interval I, when big F prime of x is also equal to f of x. So big F prime is also equal to f of x for all x in I, in the interval I. So the key thing for you to understand, sometimes I write down as a big F prime of x, sometimes I write down f of x. So let's look at the side by side, right? If I go in the highest level, which is f of x, if I take a derivative, right, I'm gonna get a f prime of x. Does that make sense? It's equal to f double prime of x. If I take a derivative, it's gonna be that way, right? That kind of logical makes sense, right? But they also says it can be equal to f of x as well. So a capital derivative can be a non-capital f, or a capital prime of x, or non-capital f of prime of x. So, and if you go up, it's called integrations. If you go up, if an arrows point upward, it means just integrations. So let's start something relative easy. Let's start with say, hey, can you find general solutions. Well, what does general solution mean? We're going to talk about it. Of a differential equation. Of y prime is equal to 2. So what is a general solution? Well, general solution is to find out the original functions. And there was two types of solution. There was general solution and there was particular solution. So what do you think if y prime is equal to 2? What do you think y is equal to? 2x. There was a slight problem with this, though. So there was a slight problem. There was a little problem, right? With just 2x. And I'm going to explain to you why. Because if y equal to 2x plus 1, y equal to 2x minus 3, what's the derivative of those two functions? They are equal to 2, right? So, how do I know which one's which? The problem is you don't. So that's why I say there's a problem with that. So a correct solution is should be look like this. Y equal to 2x plus some type of constant. That's why a long time ago, we never asked you to graph original functions. Because original function could have some type of vertical shift that we don't know about. Okay, that shift could be 5, could be 1, could be -3. So it's going to go up or down by a certain integers. Or certain number for that matter. It doesn't have to be integers. Long as they are a rational number, they are okay. They can be fraction as well. Does that make sense? So y is equal to integration of small f of x, which is in this case y prime, dx is equal to big F of x plus some type of constant. Now, why people are kind of anal about, let's see, these calculus teachers are kind of anal about it, is because sometimes not only we want to ask you to find general solution, we want you to find particular solution, which is going to happen tomorrow, which is we're going to evaluate at C if I have some type of initial condition. So that's why in the general solution, you always have to do plus C. And most of calculus teacher will tell you, if you don't have plus C, that means all questions off. And that'll be a simple thing to miss, so don't miss that. Anything definite, indefinite integral is always plus C. And we're going to talk about the difference between indefinite and definite by later on this week. Am I going too fast? Okay. No. Okay, so that means integration of f prime of x dx, it just means f of x plus c. Or it could be written in this way, and I'm okay with this way as well, because we know this are equal to each other. So they say on the textbook it says be sure to make sure they have plus c. Let's talk about all the basic derivative and basic integrations. So we're gonna work about basic informations today. So basic derivative, and then we're gonna talk about basic integrations. Okay, so now if I take a d to the dx of some type of constant, what am I going to get?
0.
Good. So what is integration of 0 dx?
C.
Yes. Congratulations. Whitney's brain is the only one that's functional in this classroom. Other people just worry about writing down stuff. It's worried about writing down stuff. But the problem is your brain is not ticking. Okay, what's derivative of kx?
K.
Yes, now your brain start ticking too. Congratulations. What's integration k dx?
Kx plus c.
Yes, Whitney's a genius. Okay, what is d to the dx of k to the f of x? Well, technically, can I move the k to the front? Can I do that? That's a constant. Can I take a derivative of 2x and just kind of leave a 2 in the front, just take a derivative of the x as 1? So, or that could be k f prime of x. Super easy. Okay, so what's integration of k of f of x? Well, the truth is, you can take the k outside as well. So that's k integration of f of x dx. Or that could be, depends on which the version is, it would be k f of x plus c. Does that make sense? K times integration of f of x is going to be integration of f of x is equal to f of x plus c. And you're going to be like, why do I distribute that k to the c? You don't, because c is some type of constant. And we're going to talk about that c could be anything, could be any value, as long as they're rational. Now, if I take a derivative of two functions, and we're going to call it f of x plus g of x. For example, if I take a derivative of sine of x plus cosine of x, well, that just means f prime of x plus minus g of x. Does that make sense? G prime of x, sorry. Now the problem is they only work with addition and subtractions. So if I have integration of f of x plus minus g of x here, dx, and that just equal to f of x integration dx plus integration of g of x dx. So it can split, the integral can split to two different things. However, there's a misunderstanding of, so there's a misunderstanding, right? The integration of f of x times g of x is just integration of f of x times integration of g of x. That is not true. If you ever did this, that's for sure wrong. And you're going to tell your friend, no, you cannot do that. You cannot just say integration of this times integration of g of x. That is not true. Not true at all. Not true. And people have every tendency to do it. It just doesn't work. Right? It doesn't work with derivative either. Why they work with integration? If I have derivative of f of x times g of x, it's not derivative of f of x times derivative of g of x. It's actually f prime of x g of x plus g prime of x f of x, right? It does not work this way either, so this one is not working, so f of x over g of x, it does not equal to f of x over integration g of x. If you do this, you kill all kind of rule in math. So not true, both not true. So don't misunderstand this. And that's what people always tend to do. They create their own rules, even though you told them only work with addition and subtraction. It does not work with multiplication and division. You cannot, one rule sets all, right? This is not the case. Now, we're going to talk about the most important rule today. The most important rule today is d to the dx, x to the n. We should know how to take a derivative of this. What's the derivative of this? Well, we drop down to n, x to the n minus 1. And we're like, yeah, we did this like so many years already. It feels like years we've done this. But here's the thing. Do you know what's integration x to the n dx? Now, you're going to take your brain a little bit. Think about what's integration x to the n. I don't want to just Whitney do all the thinking. I want that other people do the thinking as well.
So I have a question about the antiderivative. I still don't get
Which part?
Of the antiderivative, I'm not sure what capital F of x even means.
Which part? I'm gonna go back up here.
Yeah.
Okay, so think about it. If I take a derivative f of x, right, is that gonna give you f prime of x? So integration of f prime of x is equal to f of x. It's basically this car is driving forward, and what's the backward? What does the car look like before? At a location
I
before.
get that part, but what does the capital F of x, like how does that relate to?
Non-capital F?
Yeah.
Yeah, so I explained in the layer situation. So if I take a derivative of big F, it's equal to big F prime of x. That kind of makes sense, right? And that's equal to F double prime of x. But we also know that this is true as well. So if I take a derivative of big F, I can also call it, instead of call big F prime of x, I can call it small f of x. That's just another way to written the same exact thing.
So it's the same thing.
Yeah, so f prime, big F prime of x is equal to non-capital F of x. It's just a notation. We have to set up a notation so people can understand the layer difference. But the f of x, they all stay the same. Does that make sense? If I take a derivative, I can either write it this way, or I can write it in non-capital F. Now, if I take a second derivative, they just this take it to another prime. Understand? No, it's okay if you don't understand. You're supposed to ask questions. That's how you make it smart. Smart. Okay, what's integration x to the n though?
X to the fourth plus c.
X to the what?
Oh, x to the n plus c.
No.
It would just still be x to n.
No.
Isn't there like a U?
No.
X to the 1 over n.
No.
Where did the U come from? What is this?
I'm just trying to.
There's a use substitution later, yes.
Okay.
But it's not here. This is called a power rule.
No. Let me just go to.
So this is called a general power rule. There's a power rule here. So there's a power rule for integrations and derivative. But there is no quotient rule for integration, and there's no product rule for integration. There's only power rule. Only rule that applies.
Could it be like, so just take the integral of x of n, so it'd be like x n plus 1?
Good? You're missing something though.
Okay, 1 over n times x, is that?
1 minus x, or 1 x minus 1.
That's like when you bring the n down, right? It's like say you're taking.
So you want an n plus 1 to cancel, right?
Divided by
You
Yeah.
divide it by not 1,
1. Oh,
N. No. N plus 1?
n plus 1. Thank you.
I thought it runs really.
So it kind of makes sense, right? If I take a derivative of x to the n plus 1, do I bring the n plus 1 down? And the n plus 1 would cancel. And that n plus 1 minus 1 is to go back to x to the n, which is kind of make completely sense. It's like, holy. You can find stuff by using this. Okay, so now let's talk about general integrations, all the general integration. This one we should know. D to the dx of sine of x is equal to cosine of x. You should know this. What's d to the dx of cosine of x? Do you remember? Negative sine of x, right? So this is the one with negative. Okay, so what's d to the dx of tangent of x? Secant square of x. So those of you guys that remember still, which is awesome. What's d to the dx of cotan of x? Negative.
Secant times 10.
No.
Cosecant times 10.
No.
Negatives.
Cosine.
You guys are horrible.
Like cotangent.
No.
No, it's applied cotangent.
Why is there a C?
I'm trying to help you.
I thought it was negative secant squared times.
Oh, wait, is it cotangent?
Oh,
No.
cotangent times secant.
No, cotangent is cosine times secant. Nope.
No.
It's something.
Yes, something, of course. Okay, at least look at a damn board over there.
Oh,
Wow,
secant
secant
squared
squared
times
times
Yeah,
Oh, wait,
It still doesn't make sense.
Oh, negative.
And they are look, cotangent, they are same family, right? This is gonna give you same family, secant square and versus negative cosecant square.
Yeah, I was thinking of secant.
Okay, d to the dx of secant of x. Well, that's gonna give you the sexy 10. This is the one that you're thinking of.
Yeah.
And the cosecant of x is equal to cosecant of x, cotangent of x, but there is a negative sign. Anytime you have a c, you got a negative sign. So just remember, this is a one type of situations, and this is a one type of situation. This is one type of situation. Now I usually remember this, and I usually remember sexy 10. I usually remember this, and that's usually the three I choose to remember, and I just remember the other one. It's going to be a counterpart with a negative sign because there's a c right here that's going to give you like this. However, integration, that doesn't really work completely, so we're going to have to kind of figure out what happened. So what is integration of cosine of x?
Sine of x.
Okay, you're missing something.
Negative.
No, plus c.
No.
Oh.
Okay, what's integration of sine of x?
Negative cosine of x plus c.
Thank you. Why is it negative in this case? Well, you think about it. If you take a derivative of the cosine, am I going to get sine? No. If I take a derivative of cosine, I'm going to get negative sine. So you want it to be negative, so negative can cancel out. Does that make sense? Okay, what is the integration of secant square of x? There's dx on all of them, sorry.
Tan x plus c.
Good job. Now your brain is thinking. Okay, what's integration of cosecant square of x dx?
Cotangent x plus c.
But there's a missing something.
Oh, so we just have to put the minus sign.
You had to put a minus sign. Good job. What's integration of sexy 10?
X.
There you go. That's what I meant to say. I didn't mean to say that.
Sure. We all know what you're thinking of.
Sure.
Okay, what's integration of CSC of x, COT of x? By the way, that's Ani, live stream. People, it's not me. I just want to get that clear. Negative CSC of x plus c. Does that make sense? So the only thing is we do miss some integral though. We do miss something like integration of tan of x, and we're gonna say that's question mark. We're gonna have integration of secant of x, question mark, integration of cotangent of x, question mark, integration of cosecant of x dx, question mark. All those we haven't learned yet, and we're not gonna show you until the time is right. Okay, so now we're gonna talk about what's integration of 3x dx.
Small question.
Yep.
Why is it 3x? Why does there have to be a dx after that?
We didn't talk about that part because we're supposed to talk about a section called differential. But if I have y equal to 3x, right, like this, you do differential, it's going to be dy equal to 3 dx. So we didn't talk a lot about part, but just take it for granted. The dx is actually a small changing of increment of x. Later on, we're going to talk about what that's the significance of it. So right now, don't worry about it. And we're just says, just always there. Basically, it's never you have integration without a dx. Always dx just kind of there. Okay, so do you guys know what integration 3x dx is?
X to the 3 plus C.
No?
Actually, that's, wait, what would be,
Can I take a 3 outside?
It's a great question.
Yeah, it's a constant.
Oh, so would it be 3 over 2, something like that? X
Yeah.
squared? Yeah.
3 times what?
X squared?
Yep, 1 plus 1 over 1 plus 1, right? I don't need to write down. Because that's 1 plus 1 is 2, last time I checked, is 3x squared over 2 plus c. You don't have to be a calculus student to know how to do this. You can be as like kindergarten. You can do this. Except you won't know the reason why. So integration is anybody can do it. It's not like you have to be able to be a rocket science to be able to do integrations. Does that make sense? Are we okay? All right. Now, I'm going to talk about this rule again for the second time. X to the n dx equal to x to the n plus 1 over n plus 1 plus c. Now, there is a hidden situation. After rewriting process, I will integrate. And after integrate, I will simplify. Make sure no negative exponents. So make sure no negative exponents. So here's a question for you. 1 over x cubed to the dx. What do you guys got?
I got negative 1/2 times x to the negative 2.
Okay, that's good. That's good. So first of all, I will do this. Did you do this?
Yes.
And then did you do -3 plus 2 over -3 plus 2? Did you do that? Plus c, right? Plus 1, sorry, my bad. Plus 1. And then x equal to -2 over -2 plus c, right? And that's equal to 1 over -2 x squared plus c. Make sure that you don't have a negative exponent at the end. You're just going to be positive exponent, so you can change sides. Is that too hard? Try again. Sorry, let me change this. 1 over 2 square root x dx. Okay, what'd you guys get?
I got 2 over x squared plus c.
Anybody else?
-4 over root x plus c.
Almost. Remember, I have to rewrite it. This one is going to be -1/2. Does that make sense? What happened if you plus 1?
It's gonna become
1/2. Times 2, right? Divided by 1/2. If I divide by 1/2, the same thing's times what? The same thing's times what?
It's 2.
That's it. Keep change flip. And there's no negative sign there because if I integrate that, it's going to be positive. Does that make sense? What's the integration of dx? It's like a very simple question, but it's always confused a lot of people.
Is it c?
No,
0.
no,
Nothing.
no,
Okay.
F prime of x.
no.
But like, there's no d of x in the
One?
answer though.
You're on the right track.
It's true to the first power.
There's a 1 there.
So it would be
X.
1.
Yeah, x plus c.
Oh, x.
Okay, so remember that we talked about it can break up to pieces, right? So let's just say x squared plus 2x plus 3, like this, right? They can break up to pieces, but I'm just going to do integral because they are simple integrals. So it'll be x3 over 3 plus 2x squared over 2 plus 3x. Does that make sense? Does that make sense? I just take integral of those. And they can, this addition and subtraction, which is fine. Multiplication, division, that's where they have problem with. Do you understand? Yes? No? Maybe? Okay, so here's my thing. What's integration 2x plus 3 square? Don't kill puppy. I know you have every tendency to want to kill puppy. I mean,
Can we treat 2x plus 3 as just a variable?
no.
Can't just like FOIL.
Yep.
Okay. Wait, you can what? Oh, that's what we're doing.
Expand them. Can we expand them? So what is it? 4x squared plus 9?
No, it's 4x squared plus 12x plus 9.
There you go. Don't kill a puppy, right?
I thought
I thought you meant to find my answer.
you- Yeah.
So that should be 4x squared plus 12x plus 9 dx. And you should know how to take the integration of this now. Are we okay here?
For those of us that are a little confused,
Which part?
just, oh, you figured it out. Okay, well,
No, you did fine. How do I take the integration of this? I was thinking about algebra first before you do anything.
we have to do the product rule.
Huh?
We have to do the product rule.
No, there's no product rule, there's no quotient rule.
It's power idiot.
Only power rule. What can you do here?
Bring the X up.
What?
Bring the X up.
No, I won't do that. I mean, I see what you're saying. You might go in somewhere with that, but yeah, but I won't do that.
Is it just x over square root of x plus x to the negative 1/2? You split them?
Exactly, you split them. And that x to the 1/2, that means x to the 1/2. Does that make sense? X to the 1 over x to the 1/2 equal to x to the 1/2. Because top subtract bottom. Plus x to the negative 1/2 dx. Does that make sense? Did I take integral yet? No, I just do algebra first. So it'll be x to the 3 over 2. 2 over 3, why I flip? Divided by 2 over 3 over 2, so it's going to be 2 over 3. Plus x to the 1/2 and 2 plus c. So I did it in my head. Does that make sense? Let's put two things in combinations. Let's say x plus 1 square over x dx. So I want you to do integration of this. And second one, I want you to do integration of this. Square root of x times, or x to the third times x minus 2 dx. So how do I do integration of those two? So I will expand the top, right? Can I expand the top? So that'd be x plus 2 square root of x plus 1, right? Does that make sense? Am I going too fast? 1 plus 2x to the 1/2 plus, ooh, I'm sorry, this one's not possible to take integral.
Would you get a 0 as like a exponent?
Yeah, I'm sorry, let's change that bottom part to square root x. I'm sorry, because integration of 1 over x is not integrable, not ever yet. So let's change that to square root x. That makes it a little bit different. That's my fault. Integration of x to the 1/2 plus 2 plus x to the negative 1/2. Does that make sense? Because that's not possible. Not possible as of now. Not possible as of now. That was my fault. And this one's going to be x to the 3 over 2. 2 over 3 plus 2x plus x to the 2. No. 1/2 and 2 plus c. I knew something wrong with that questions. Does that make sense? Is that hard? No? How about this one? What can I do on this one? What can I do on this one? Can I distribute this?
Yeah.
X to the which power?
1/3.
What?
1/3.
No. Oh, well, 1/3 times 1 is what? X to the 1/3 times x. This is 4/3, right?
Oh.
And if I do integration, this one's going to be 7 over 3. 3 over 7. Minus 2x to the 4 over 3 times 3 over 4. So it'll be 3 over 7 x to the 7 over 3 minus 3 over 2 x to the 4 over 3 plus c.
Do we have to repeat that?
Yeah, it's already posted.
Mr. Yay!
There we go.
How much did you miss me, Mr. Yay? On a scale of 1 to 1.
Can I go negative?
No, it's 1 to 1. That hurts my feelings, Mr. Yay. My feelings are hurt.
I'm gonna go in.
Mr. Yay was having withdrawals from me the whole video. He's like, I need my baby close to screen.
Yeah. Okay.
Daily dose of chaos. We could say, oh, we're doing integrals. Can I not?
Integrals? More like derivatives, but backwards.
Is it
Because
actually?
that is what they are. Yeah, Mr. Good. Yo, you look swag. I'm rocking out the jammies. You know, these are all
I didn't know today was the
Me neither. They're on a men's medium, so I have to go for the woman's XXX now. So
Dang.
I'm feeling like a plus size curvy queen right now.
Nice.
A fluffy king.
Fluffy king.
Or no, a fluffy queen. Oh yeah, hit the forehead. Hey, what is with you getting in fights with people in our clan? What's going on?
I antagonize for the sake of antagonizing.
Who is a god one?
Agon 1 is like a freshman that Lucas Dvorak knows in like what is it, Wintercraft.
He goes to Whitmer. Why is he in our clan?
Because he's like the best player in our clan.
Dude, I could be that.
Hey, good.
Literally, it's just garbage.
Sorry.
Let me guess. Use this lumberjack.
Yeah, he uses Lumberwind.
My fellow brother.
But he uses Lumberwind cycle.
What?
Yeah.
Yeah, the country
So did you kick him out of land or?
Yeah, I didn't kick him. Sean did, and then we just retyped him right after. So I kicked him and then I.
Why is he a co-leader? He's like a freshman.
I know, but he's like insanely good.
Freshmen have more
Actually,
time
he's
to
second
waste
place in
on
the
paper.
clan. And why am I not a co-leader? I've had like top donations and top.
That's facts.
Because
Are
you're
you
sus.
What?
Are
I'm
you-
an elder, but I've been an elder since I like joined.
Okay, that's
Giving
because you're
elder.
facts. Life-size homework.
Wait, is Swedish Fish back? I thought they kicked it.
Okay, so we kicked him, and then he joined back demanding a 1v1 for his honor.
What?
Good morning. I wake up in the morning, brush my teeth before I see my queen. Wow.
Wow, you are.
Wow. Would I be singing the second part well?
Huh?
Would I be singing the second
Okay,
part?
ready? Wake up in the
No, I can't do
morning,
it.
brush my teeth before I see my queen. And then the transition?
It's just me. Oh my goodness, I'm your queen, Will.
You are my queen. Mr. Ye, how was your Thanksgiving?
Good.
That's good.
Mr. Ye, what's up?
I know your weekend didn't go
Yeah.
as
up. Heads up.
planned. Florida's bowl eligible, baby. Oh, Florida beat Ohio State in basketball, too.
Please.
Mr.
Who cares? And you guys had a game winner. Like, who cares? Like,
Mr. Ye, what's your favorite meal?
Ohio State is the
Part of
TikToker on their
Thanksgiving?
basketball team. You know that? Ohio State is the
Huh?
TikToker on their basketball
What's your favorite meal
Oh,
as
yeah.
part of Thanksgiving?
I know, Jimmy Soda.
I'm vegetarian.
He's so
Oh,
bad.
He's literally a
Okay,
bench
you
player.
are.
He's like their worst bench player.
No,
What's your favorite
he plays a lot.
vegetarian
He does
meal?
play a lot. He played like a whole Florida game and shot like 1 for 18.
What's your favorite
Like, he's so
vegetarian
bad.
meal?
Stick to TikTok.
And
Pretty
he's
cool.
a senior.
Vegetarian
He's a senior.
meal?
That's
Yeah,
what
for
he's
Thanksgiving.
Dumpling?
Dumpling?
Look, I'll pull it up.
Good.
He has this like six-packing really pearls.
It's totally not
Come on,
turkey.
bro. Like, this is
I don't know.
bad.
I normally hate turkey, but this year I had the best turkey of my life. So now I'm a changed man.
Turkey's always so dry, bro.
Yeah, this year I had like a nice moist turkey, bro.
Balling out. Oh.
Yo, who bow well? Who bow? Who bow?
I do.
She's so good, that's
So bad.
Yo, Will. You young bloods don't know how I run it, though.
Pack the rock, bud.
Oh,
my
Carrie,
goodness.
Carrie.
Oh my god.
Dude, Ramon
I'm so wrong.
It was literally terrible.
I was gonna come down. I was like,
Oh, play basketball.
Yeah.
I play basketball.
You probably be Ramon.
So cute. You're
Thank you. He's like that.
You wear your Crocs to bed too.
He's also like fine.
Yeah, I do too.
She got text messages for us.
You got a haircut?
Oh
got a
my
haircut?
goodness.
You got a haircut?
oh yeah, I did.
I'm the tester.
Mr. A noticed faster than I did. I mean, he didn't notice my first one.
Because it looks different.
They're actually
Yeah.
phenomenal in terms of sweat.
They probably look older.
It does.
Yeah.
More mature, probably.
Yeah. It's giving me like parent energy.
Wake up in the morning,
In a
brush
good
my
way,
teeth
in a good
before I
way.
see
In a
my
good
queen.
way. In a good way. No, I'm not talking to you.
Oh my
Alright,
god.
guys.
It looks good.
my gosh, you can
I
always
like it.
Shut up, we're learning integrals. Okay, Mr. Ye, go ahead.
Alright, so.
Go ahead.
Alright, let's go. Let's do it. Let's do this. Yeah, I didn't give you homework because I don't feel like it. So,
Tonight?
Aw,
No homework tonight?
no, there's homework today already.
I was about to say no homework tonight.
No, I mean talking about Thanksgiving week.
You said there's homework today?
Yeah. Alright, so, no, today's homework is actually relatively easy.
Wait, what? Mr. Suggs isn't here. Mr. Suggs just decides to dip he needs an extra day to break.
Alright. Alright, thank you. So we're gonna get going with this because it's kind of long and boring lesson. So I just want to get done as fast as I can. I feel like this is the third time I do this today. Well, this is the third time I'm doing this today. So I'm kind of sick of it already. There's something that it's also like a lot of times like people were struggling before. is now it's a good chance to reset because we are talking about second part of calculus, which is the antiderivative part. So we're going to talk about, let's review of derivative. What can you tell me about derivative?
It is a way to calculate the rate of change or slope of a line.
That's actually a very, 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 very good definition. It's a way to calculate slope of a line, and it's a way to calculate the rate of change. And so the rate of change is actually pretty important because we've been talking about derivative for the whole 3 months. It's hard to imagine we already know each other for 3 months. It feels like longer. I'm serious.
That's so sweet.
Okay, so
I'm gonna cry.
I'm making glad this VA.
huh?
I add some spice to the class, just like Will does sometimes.
Spice.
Thanks.
Bro, I need some spice. I cannot find Sprite, cranberry, anywhere.
Nobody can.
Dude, I've been looking so hard.
All right, so
Antiderivative.
antiderivative. Thank you. Antiderivative is we also known as integral. Yeah, don't say integral, please. It just hurts my heart when I hear people say that.
Say more now.
Huh?
Without the
Integral, or sometimes people think about it as an integral will be talked about specifically is indefinite integral. Indefinite. And we're going to talk about what's definite integral later. Indefinite integrations. So it could be like that. Now later we are going to talk about what does definite integral mean. So definite integral is more closer to slope. So a definite integral.
Say integration.
Integration here, yeah. The definite integral is also known as area under the curve. So instead of looking for slope, I'm looking for the area under the curve between the curve and the x-axis. So those are the meaning of the arithmetic meaning of the integral. But we have some problem that we're going to foresee. So here's the thing. Let's start with some simple things. Let's say f of x is equal to x to the cube. And if I d to the dx to the x to the cube is equal to 3x squared. Therefore, we can say 3x squared is the derivative of x cubed. But we also can say x cubed is the antiderivative of 3x squared.
Oh my god, that's crazy. It's a backwards derivative.
Oh my god, that's like.
That's what I've been saying.
So, but if you learn, like, if you realize in math, it's always been this way. It's always driving a car forward, driving a car backward. First, you learn about addition, then you learn about subtraction, and then that's the first grade. And the second grade, you learn about multiplication and division. Holy shit! It's always been the same thing.
I mean, I didn't learn about it because I'm still struggling.
Okay. Also, they also might, if you're gonna go into high school, you got a positive slope, you got a negative slope, you got a inverse function, which is y equal to x squared. The inverse of x squared is square root of x. They are called inverse. So something going backward and forward is very consistent in mathematics. So there is a forward process, there's a backward process. For example, logarithm versus exponent, sine and inverse sine. And there are so many things happen in math, it's always repeated. It's just, you learn forward and you learn backwards. But the thing is, I always tell students is, a lot of time people focus on learning forward and not learning backwards. But really, if you drive a car like you've only learned how to drive forward, then that's bad because you can't even get off your garage, right? unless you want to make a
What if you
hole
put
in your
into-
garage,
Put it into toe, and then like you push it out every time.
a hole. Unless you build a garage, it looks like it's just a shed and it has both ways. Just
Hey, Mr. You know Ohio State actually lost this season.
Shut up.
They got real mad.
all right.
Ruining their playoff chances.
We talked about this before. So
I want to talk about it, Miss J.
So here is the things. So now also, we want to talk about one more thing, that this thing is kind of interesting. A lot of people got confused earlier period. Hopefully I can do a better job explaining this part. So definition of antiderivative.
Integral.
Okay, so they say a function's f is going to be in black, f is an antiderivative, so is antiderivative of the non-capital F. So knowing the relationship between capital F and non-capital F. So big F is antiderivative of non-capital F on the interval
Are antiderivative and integral like interchangeable, or are they different?
Yeah, it's interchangeable usually. That there are some things that we're gonna talk about later. It's called definite integral, and you don't say definite antiderivative. It's just kind of awkward to say that. But yeah, in most of cases you can say that, but it just sometimes it doesn't really sound right. On the interval I, when f prime of x
Wait,
is equal to f of x.
that says I, A, win.
I.
I, win.
When big F of prime of x is equal to f of x. For all x in I. Now with that being said, that there is something that a lot of people get confused. So I'm going to write down in layers so that will help you. So f of x is equal to f of x. That's true. That's a true statement because that's just 1 is equal to 1, right? We can also take a derivative. So that's a derivative. That's going to give you f prime of x, right?
Yeah.
Now, on this side, it can be f of x. Why? Because integration of small f of x is equal to big F of x. So therefore, derivative of big F is also equal to f of x because this right here. And then f double prime of x just equal to f prime of x. So kind of know the relationship with non-capital F and capital F. So that's the notation difference. We have to set up a notation. Do they always this type of notation? No. Sometimes we can say, it's g of x. It's, integration of f of x. So it just right now, this is going to be the same. This is going to be the same. A lot of time people get confused. Why do I change from a capital F to a non-capital F, but this time without prime? But just tell you, the big F of x, if I take a derivative of that, it's going to be non-capital F. Okay, so this is a very, very boring part. Now let's get to something more exciting. So if I have y prime is equal to 2, what is y? Tom? 2x? So you say y is equal to 2x. Now the problem is there's a slight problem here. There's a slight problem. Can somebody tell me where the problem lie? If he's not entirely wrong, he says y prime is equal to 2 and y equal to 2x. Well,
technically, the function could be 2x plus 17. You know what I'm saying? You could have an extra
That is so
number
fast.
that you would know that.
Exactly, because what, good job, by the way, d to the dx of 2x plus 17, like he said, versus d to the dx of 2x plus 3 versus d to the dx of 2x, they're all equal to 2. It didn't matter because derivative of 17 is 0, derivative of 3 is 0, derivative of 0 is 0. So it still end up with 2. So we had to show you that this one here, it's actually have to including something very important. That C has to be there. It's called general. This whole thing called general solutions. Okay, general solution is basically, it says 2x plus c. Could be anything. Could be 10. Could be 2000. Could be pi. You know. So it could be any rational number that it can be. So that's 2x plus c is the general solution. Now, what's the difference between general solution and particular solution? We're going to talk about later. What is general versus particular solution, which is we're going to talk about tomorrow.
It could be any constant.
Well, particular solution is like saying my original function is going to go through the coordinate 2, 3.
So it has to be in a set of certain numbers.
Yeah, in a set of certain number, exactly. It's because you have 2x, right? Now 2x, only one c is going to be exactly 2x. That exactly you have a coordinate of 2, 3. So therefore you can find the value of c. So yeah, that's something a little bit more thinking for tomorrow. But today it's just general solution. General solution just basically find out something plus c. Now if you don't write down plus c on your test, I'm sorry, because most of calculus teachers pretty anal about the situation. And I mean anal, really. I am as well, unfortunately. Because I'm usually very laid back on the situation, but the C is very important because you need to find out what C is. Because C could be anything, but sometimes if you want to find general solution, C would be enough. So let's review again. Integration of f of x dx is equal to f of x plus c. Also, I can rewrite as f prime of x dx is also equal to f of x plus c. There is no difference between those two. It's just notation difference. So because we already established f prime of x, capital F prime of x equal to f of x, so it doesn't matter which equation it is. So let's talk about some basic rules. The basic derivative. And this is a very, very dry, yes. We'll get to more exciting things later. Derivative of the constant is equal to 0. That's a very, very giving. Easy giving. What's the integration of 0?
0.
C.
It's just actually c.
Yes.
It's just backwards. Antiderivative. So basic integrations. Okay, d to the dx of kx. Just k. What's the integration of k?
Kx plus c.
There you go, there's c. Because c has to be there in order to work. Derivative of k fx is equal to, well, we can take a k in the front, d to the dx of f of x. Does that make sense?
Yeah.
I can take a k outside, just like we would take a derivative of 2x squared, we take a 2 outside, just take a derivative of x squared. So derivative of k, derivative of f of x is going to be f prime of x. Integration of k f of x. Well, that just means k, integration of f of x dx. So you can take a k out of derivative, you can take a k out of integration as well. Very, very useful situation. Very, very useful. And that's very, very easy. If I have d to the dx of f of x plus minus g of x. Now this one's important. It's f prime of x plus minus g prime of x. Now integration of f of x plus minus g of x dx. Now the problem is, this one's just going to be integration of f of x dx plus integration g of x dx. This is a simple idea, but a lot of people don't understand it. The integration can add and subtract. However, it never said you can multiply or divide. Okay, never. So a lot of misconception on the test is people think, like there was a misconception, right? Is people think about integration of f of x times g of x dx is equal to integration of f of x times integration of g of x. Not true. A same thing as the integration of f of x over g of x is equal to integration of f of x over integration of g of x. Not true. So please do not do it. Only work with addition and subtraction. It does not work with anything else. First of all, there's no product rule. Or derivative of f of x and g of x is product rule. Derivative of the quotient is a quotient rule. Never says that's derivative of f of x over derivative of g of x. Some people did that on the derivative test, but those are not true. So please realize that this is entirely false. People's gonna make up shit like this all day long, but it's not true. So don't worry about this. Just say that is not true. Please don't do that on the test.
Wait,
Okay.
so why do you add the dx after you do the integral?
Well, that's a very, very good question. We're supposed to cover this section. We're supposed to cover one section before this section. It's called differential. So differential is like if you take a y to the x squared. If I take a differential of this, it's going to be dy equal to 2x dx. Kind of like derivative. If you divide by both sides by dx, it's the same thing. But that's called differential. So dx is also there. Dx is a small changing of x. Okay? Small changing of x. That later we're going to talk about a little bit more. As of right now, we're just going to ask you, it's always there. If you did derivative integration of x, it's always have dx. Integration of y, you always going to have dy. Integration of data, you always have d data.
So there are you doing an integration of x, and then it's equal to dy? No, at the bottom where you do y equals x squared. Oh wait, no, you have derivative y. Okay, now I see it. Never mind.
So this is called differential.
Yeah.
This is not derivative, it's differential. It's just take it, just like d without any respect anything. So
Alright.
d will be, if I y, then it's going to give you dy, and equal to 2x and then dx, which is derivative of x squared is 2x dx. So if you divide by both sides dy dx, it's going to give you dy dx equal to 2x. But this is called a differential. And we didn't cover the section. I purposely didn't cover the section because I don't think that's that important until right before the test. Because we can put all the pictures together. And also get review for something else. So now, we're going to talk about the most important rule. D to the dx of x to the n equal to nx to the n minus 1. This is called power rule. Remember, there are no quotient rule, no product rule, no other rule except power rule in term integrations. So what is integration of x to the n dx? Can you guys figure out this? Do you guys know what integration x to the n dx is?
Isn't it just n?
X and plus one.
Oh, it would be x divided by n to the power of n plus 1.
Yeah, plus 1.
Almost.
N plus
X
1 is the
divided
thing,
by n
right?
plus 1.
What?
X divided by n plus 1 to the power of n plus 1.
Oh, that's what I meant to say.
Good job. N plus 1 over n plus 1 plus c. Well, why is that? If I take a derivative of this, right? think about if I take a derivative of this. If I d to the dx this, the n plus 1 is going to be in the front, x to the n plus 1 minus 1. Does that make sense? Over n plus 1. So the n plus 1 will eventually cancel out. This one becomes x to the n. So that's the antiderivative. Does that make sense?
Wait, can you leave it there for just a second?
That is crazy.
That doesn't.
Very, very, very useful situations, okay? So this is the only rule you have to deal with integrations. There's no other rule. Well, there's other rule that involve a different situation, but this is the only rule for us, just a polynomial. So we're going to talk about all the trick one as well. D to the dx of sine of x is equal to what?
Cosine?
Good. D to the dx of cosine of x?
Negative sine.
Negative sine. D to the dx of
Negative sine.
tan of x?
Oh, this is gonna hurt my brain.
Secant squared
Gosh.
sine.
Oh, sexy tan. Wait, no.
Yeah.
Sorry.
Oh yeah.
Twice.
There you go. Good way to remember it.
I'll never forget
I approve that.
The one.
Which is?
That's your first
It's kind of
time.
sad.
Huh?
It's kind of sad.
I know. Well, whatever help you remember. If you help you get a 5, you can remember however way you want. Okay? So d to the dx of cotan of x, CSC square x, d to the dx of secant of x,
Sexy tan.
Tangent.
Yeah.
Set up x tan.
And of course, secant is negative cosecant x times
Negative cosecant cotangent.
Boo.
Okay, so now that means there's an integration counterparts. So integration of cosine of x dx is what?
Oh, negative
Negative
sine
sine
x.
x.
No, wait.
No, it's just gonna be
Sine
sine.
x.
Just sine.
Oh, yeah, that's.
Yeah, because the derivative of sine is cosine. Okay, so integration of. Do you have to go?
Yeah, I'm using the bathroom, but now I'm like really invested, so like I'm gonna wait. I'm gonna wait for this, and then I'm gonna use it.
Don't shit on your pens.
I honestly, I'll make do. I'll do what I gotta do. Even if it means like I shoot for
I appreciate you, but you gotta go. You gotta go.
Not that bad. I'm like so invested right now.
Okay.
Bro, you do you.
Negative cosine x.
Negative
Plus
cosine.
C. Oh my goodness.
Yes, negative cosine of x.
Actually, it would be minus negative c.
What's the integration of no, sorry, secant square of x,
Back there.
10 of x plus c, because derivative 10 is secant. Integration of cosecant square of x dx is what? Negative.
Negative cotangent. Plus c.
Okay, integration of secant x 10 of x. Secant of x plus c, good. What's integration of cosecant of x cotan of x?
Negative cosecant x plus c.
Okay, so those
You forgot the dx in both of those two.
yep. Okay, so now one more thing is there's something that we don't know and we're not going to talk about late now. So integration with tangent of x dx is still unknown as of right now. The story has not ended yet. So tangent, cotangent of x dx, they are not knowing. Integration of secant of x dx, not knowing. Integration of cosecant of x dx is not knowing.
That's true, because they're like, you gotta put them in pairs for them to make sense. Because it goes from two things to one thing.
Right,
if
so
you just have one, it would be like the root of something.
so we still don't know this. We still don't know this. And the things about this is very, you're not going to know this until chapter 5. But right now we're just going to deal with the basic derivative. The basic integration. So what's the integration of integration of 3 dx is, 3x dx, sorry. 3x dx.
That would be 4x to the power 4.
Nope,
Oh wow, I did mess that up. X to the power 4.
no,
X. Oh my goodness. I should just do it.
Plus 3.
no,
3x divided by 4 to the power 4.
no.
Dang it.
It's something with x to the n plus 1. I know plus c's at the end, I can tell you that.
Good job.
Wait,
Um,
no, it's something like.
1.5,
No. Oh, well, hold on a second.
1.5 x squared,
Yep.
1.5 x squared plus c.
Well, here's the thing. You can remember this 3 can be outside, right?
Yeah. Oh, well,
And that's 3 to the 1, right?
yeah.
So it'd be 3x squared over 2 plus c.
So it's 3 divided by 2, which is 1.5.
Well, I got it. Just, I just thought about it instead of just doing that.
Yeah, there was a small problem with that, but we're going to talk about it in a second. So does that make sense so far?
Yes.
Okay. So now let's revisit that rule again. Now this rule is very particular. Is equal to x to the n plus 1 over n plus 1 plus c. Now why is this rule in particular? Because this x to the n is always numerator. It's equal to the numerator. It's on the numerator. If it's not on numerator, you're going to have to make it to become numerator. Okay, so that's why I told students always very important to rewrite something before you take integral. Rewrite something thinking about algebra all the time. Rewrite something thinking of algebra. Because algebra is going to be the foundation of everything else. So then you say, okay, well, what does that mean? It means I will tell students to go with the original integration. I will always to rewrite it to x to the n on numerator. If it's not on numerator, if sometimes already on numerator, you don't have to rewrite it. And then after that, I would integrate. And after that, I will simplify. What do I simplify? Simplify means in algebra 1, no negative exponents. No negative exponents. And this is very important. So how about this? How about, can you take an integration of this? 2 over x to the 3.
I can do it.
You could, but don't want to.
Would be negative x squared, or negative 2, no.
Sometimes it's good to be patient and just think throughout instead of just jumping to conclusion.
Negative 1 over x squared.
Negative x to the negative 2 plus c.
Negative 1 over x squared plus c.
Negative what?
Because I have
1 over x squared plus c.
I have 2x to the negative 2
I think negative 1.
over minus 2 plus c, but then that would transfer and then you just cross out the 2's, so you'd have negative x to the negative 2 plus c, right?
Now remember, there's no negative exponent on your answers, right?
Yeah, it's negative 1
Oh,
over x
oh,
squared.
So-
it'd be negative 1 over x squared
Plus c.
plus c.
That's what I got.
Yep, that's what Hung got. And then so this is going to be x to the negative 2 over negative 2, right? Over 2, right? Plus c. So the 2 cancel out. It'll be negative 1 over x squared. Does that make sense? Plus c. So even though it's something very easy, but there's a lot of things that you can mess up if you rush through it. So there's no reason to rush. You have enough time. You just have to process and think and process and think. So let's try another one.
I'm gonna get it this time, Mr. Guy.
So 3 over square root x dx.
I'm ready to learn now.
Pressure is being released.
Yeah.
Is it 1/2 the root of 1.5 root x plus c?
I don't know. I didn't do it, so you guys gonna have to.
2x to the 1/2 plus c.
It's not 1/2. It's a half of 3.
Or, yeah, it's 2 square root x. 2 square root x plus c. Yeah, 2 square root x plus c. Well, you gotta add in the,
Oh, it's divided by a half. It's 6x.
you gotta add on, the yeah, so 6x.
I'm sorry.
6 square root x plus c.
So remember, this is 3, right? We can take it outside
What?
to the x to the negative 1/2 dx. Did you do that?
I didn't. I left it in and I did the whole thing.
Okay, yeah. I mean, more power to you if you know how to do it, right? So negative 1/2 plus 1, right? Over negative 1/2 plus 1. I usually don't write this out. I just help you right now. Just write it out so that way to help you. 3x to the 1/2 over 1/2. Does that make sense?
Yeah.
Now it's keep change flip, so it's gonna be 6x to the 1/2 plus c. So it's 6 square root x plus c. That's the rewrite process. So I rewrite it to the numerator. And once I rewrite the numerator, I can take integral of this. Okay, what's the integration of dx? This is kind of a hard one.
C.
D over dx?
Is it a c?
This is x plus c.
It's c.
No, it's x plus c, because x.
X plus c.
That's what I said.
Because there's a 1 there. It's not there, but it's always there.
It's 1 to the power of 1.
You don't write down x. You don't write down 1x. But at the same time that you don't write down this part here too. Okay, what's the integration of x plus 2?
The 9.
Oh,
That's dumb.
that's easy peasy.
That's kind of like probably x.
X squared
Wait.
plus 4x over c.
Bruh, I hate having to write stuff out.
Yeah, you should.
X plus c.
X squared.
Some like that.
Wait, isn't
Is
it?
that not what it is?
Wait, can't
Isn't
you
that
just wait? Isn't it
2
x squared over 2 plus 2x plus c?
Yeah.
You guys are bozos.
It's x squared over 2.
Because there are 2 different integrals, right? Just take an integral of x, take an integral of 2, and that's it.
That's so true.
I thought it was x squared plus 4.
You got me.
Okay, I'm gonna give you a little bit harder one, okay?
It's very low.
Well, that was okay.
It's very poggers.
Oh no.
No, Mr. E.
Oh, this is cake, Mr. Guy.
I would just expand it TBH.
Oh my, that's what I was gonna do. Andrew, you're so sassy.
Shaking my head in my head.
It will take me some time, Mr. J.
I said it in my head.
Just don't kill a puppy, right?
This is illegal.
I gladly kill
I'm
a
gonna expand it first, okay? Give me a second. So you got 2x squared.
I look wonder what dogs taste like.
Then you got
2x squared, are you serious?
Chicken, to be honest.
4x squared. My bad. I killed a puppy. Then you
Kill
got, then you got,
It killed an elephant there.
you
Okay.
got 12x plus 12x.
I think I got it, Mr. Ye.
Plus 9.
X squared plus 9x plus c. It would be.
Let other people think.
Let me do it, Andrew.
Sorry, Mr. Ye. Sorry.
Let other people do it.
Honestly, Andrew.
Now you need to check your answer, Andrew. Andrew, the problem is you do it so fast, but you go in like 1,000 miles per hour, and then you do it wrong, then that's no point. So you want to reduce down your speed for like instead of 1,000 miles per hour to 100 miles per hour, and still fast. But then you can at least you drive on the road
True.
because you driving 1,000 miles and you can stay on the road.
I wrote down all the steps this time, I think, so I think I'm
Oh, yeah, it
good.
literally goes 100.
Facts, Mr. Yeah, I got it.
I wrote down every single step.
So what's the integration of?
70 on the test.
Bruh. AJ, shut up.
So it's gonna be 4x squared plus 12x plus 9 if you expand it correctly. And then integration this just gonna be 4x to the 3 over 3 plus 12x to the square over 2 plus 9x plus c.
I forgot to simplify it to.
Yo, Mr. Ye, why
When
can't
you expanded it, you multiply the 2x by 4, right?
Yeah.
And then you go to the 3 and you multiply it by 2x. So you take whatever this term is and you multiply it by 2. You put 6x, but you did it twice, because this times this, to be on this times that.
I know, I got 12x in the middle.
Okay, so we're gonna give you a couple situation. We're gonna give you this situation,
I need another piece.
and we say, hey, do you know how to do this? Whoa, this one is kind of interesting. So it's x plus 1 over square root of x. So how would I do integration of this? Shh, don't think out loud. Write it down, and we verify it together. But let other people have a chance to do it, because if you say it, other people start thinking. And your answer doesn't mean always right, so you have to slow it down to like 100 miles per hour instead of 1,000 miles per hour. If you go in 1,000 miles per hour, that you're always gonna get wrong answers. Just slow it down. It's still faster than other people.
Yeah, I think I might kill a puppy here and do the whole.
Chill
Shut up, dude.
I wasn't talking to you, alright?
Gosh, bro.
I'm talking to CA real quick. You said we can't do like the integral of like one thing times the integral of another thing.
I did it.
So like
Good for
hypothetically,
you, bro.
You should think algebra first before you do calculus. Always.
Simplify.
Always think about algebra before you do calculus.
That's what I did.
What is that?
oh.
Oh, I forgot to make it negative. Anyway, that would be.
Wait.
Don't go million. It's kind of like when you multiply, you know how it's like adding.
Yeah. It's just
That's
1 plus.
1 plus
Yeah.
It's
1.
just negative, or it's 1
It's
half.
just 1 half.
Yeah, it's just 1 half.
I did stuff wrong, Luca. Don't jump.
So a lot of people choose to move to the top. I won't move to the top. And there's a reason why I don't do that. So I'm going to show you the reason. I always divided out each term. This is my tendency of doing something, and I have my reason doing this. I think this will always lead to the right answer. And then x to the square root, then we can change that to maybe 1/2 power, right? So let's change that to 1/2 power. And I always do it this way. Some people choose to bring the x to the negative 1/2 on top. I won't do that. I will show you why I won't do that in a second. Okay? And we'll do that with different questions. So integration of x, in this case, is 1 minus 1/2 is 1/2 plus x to the negative 1/2 dx. And now that's going to be x to the 3 over 2, and then 2 over 3. I didn't even divide it by 3 over 2. I just flip it in the front. Plus x to the 1/2 and 2. And then plus c. And I'm done. Now, why I don't change to the top? I'm going to show you in a second. What if I have sine of x minus 1 over sine of x? I don't flip to the top because that's going to become cosecant of x. And a lot of people cannot see cosecant of x and sine of x. But it's much easier to see it this way. It's much easier to see it this way because that's integration of 1 minus CSC of x. And that's just going to be x minus plus CSC of x cotangent of x. So we actually talk about two questions at once. Can I give you this question for homework? Yes, absolutely. Because you already know how to take an integration of 1. You already know how to take an integration of cosecant of x. That's very, very, direct. It's not something like really complex.
How did you do cosecant? I thought you said we couldn't do those ones.
Integration of hold on a second. Oh yeah, you're right. Yeah, that's a bad question. So integration of cosecant doesn't work, but integration of cosecant is actually something else. Sorry, my bad. We don't have. That was my fault.
Yeah, you just did the derivative.
CSC of x. That's gonna be a natural log.
Natural log. I know.
You don't have to do this yet. So it's CSC of x plus COT of x. So that is actually this is positive because it's changing sign. So you don't have to do this. You don't have to do this. But just to tell you that a lot of time it's much easier to split all the time. You're gonna see things much more clearly, especially in trig. And obviously I'm making my mistake right here. Integration cosecant of x is not integratable as of right now because we didn't give you the formulas for it, and we don't teach you how to do it yet. But it's actually natural log of cosecant of x plus cotangent of x,
That makes sense.
and there's a negative sign. No, actually, it's really hard to make sense on that, so we're going to talk about that later, but it's the next chapter. Does this make sense? Yes.
For the answer that you got, and there 2/3 x to the power of 3 seconds x. Why don't you have 3 seconds x in front of
X?
yeah, in front of x instead
Because it's a divided by 3 over 2.
oh,
So
yeah.
divided by 3 over 2 should be a 2 over 3. It should be a keep change
'cause
flip.
you flip it, yeah.
Yeah, it's x to the
Okay, so we're going to put two things at one cases. So what if I have a x plus 2 square over square root of x dx? And I want you to take the integration properly here. And let's see if you guys can do it. What time we get off here? 24? Okay, you got 6 minutes to figure out this.
But it's can't figure out this.
Why do you hate us?
I got 2.
I don't know, compare with each other. I don't know the answer. I didn't do it. I just did the questions.
Yes, sir.
What is this it?
Yes, sir.
Where's yours?
Right here. I just did a little ghetto math.
That's how I did it too. Cause then you split them all the terms.
Going crazy, yeah. I feel like there's a lot more algebra than it is calculus.
Yeah, it's a algebra.
For this one.
And that's why I spent so much time talking about algebra at the very beginning of the year. People thought I was crazy.
I thought
And
you were crazy.
I am crazy, but
Also, is Sheila still in this class?
Yeah, she's just absent.
Ooh, I did some math wrong.
why she's not here?
She came from Canada yesterday, so I'm just guessing she's tired.
Oh. It's just Canada. It's not like
Yeah,
Afghanistan.
but she was there for like a whole week.
Yeah, Canada. You know how far to fly from Canada here? 3 hours.
Yeah, but it's also Sheila.
Is what?
It's also Sheila.
Oh.
She gets very tired, like really easily.
Oh, I'm tired.
Is it next to the 5
Yeah, Canada. Well, depends which part of Canada. It's like on the other side of Canada or like Toronto, Canada.
I think close to Toronto.
Yeah, then that's like 3 hours. At max 4 hours. New York.
Yeah, but if it was at like night, then she's not gonna.
Oh, Mr. You're the grade test?
No.
Wait till you see mine. I'm 90% sure I got like, one wrong or 100. Like that, oh my god.
No, yeah, it's all good. Which separates where's the math?
Did you say you're not ready? I mean, like I studied.
You did it?
I should be ready.
Good job, Boo Boo Bear.
So,
You did a great job, Boo Boo Bear.
you already added one zero, right? So then it's.
Dude, I had the best turkey of my life, bro. I've never. The turkey's always dry and garbage, bro. Dude, this had moist, bro. Yes, they had homemade gravy, bro. It was like moist chicken fillet. I kept going back for so much.
Dude, like, I've had like, I put grade on everything.
I haven't.
Put it on the
That winner mentality, bro.
It's like, I think
that
that's
last term.
It's Thanksgiving.
So, also, don't forget plus.
Bro, I would put on like 10 pounds.
Is that right?
The whole winter season.
Yeah, we've
How do
been.
you get?
That's
how do
what
you
we
get
got.
2x?
Yeah, that's so
Isn't it 8?
Yeah, it's 8 divided by 8.
Yeah, isn't it 8 divided by 3?
Oh, I did it wrong.
And then
No
8x
world would I ever
at
be
the
doing
end
water.
instead of 6.
2 over 3. I can multiply. 8 over
Bro, and
3.
AJ has it good. You know
That's so
what?
embarrassing.
I know.
Yeah, imagine getting a rookie.
I know. I just can't even multiply 2 times 4.
Yeah.
That's such a shame.
That's kind of sad.
We used to fight to get to
It happens.
It's okay. I forgive.